All right. Again, thank you for having me. I'm excited to be here and excited to talk about the gtSummary package. Throughout this presentation, if you have any questions, please just raise your hand or interrupt me. Pablo, if someone puts something into the chat, please just feel free to read it aloud at any time. We're a good sized group, so I think we can have a pretty good back and forth when needed. So first I want to talk about the motivation for the gtSummary package. We've all probably heard about this reproducible crisis in science. And while the arc of the reproducible crisis is quite large, in our role as statisticians and data analysts and data scientists, we prepare our data using raw data, and we clean that data in a reproducible manner. We do our analysis in a reproducible manner, and we do our reporting in a reproducible manner. That would be our 100% goal there. For me, I tried for many years to do this as well as I could to make it an entirely reproducible workflow. But what always something that was always difficult for me was at the end creating my reproducible reports. It seemed like I was always tinkering with the output from my console, from my statistical programming software, to the report that I was providing to either my collaborators or a stakeholder, what have you. Our Markdown was a huge game changer for us. In that we could create these reports nearly entirely in a reproducible manner, but we still found ourselves on my team futzing around with the tables and the figures, and the text was a lot of hard-coded numbers into the report. And so we wanted to bridge that gap and make a 100% reproducible pipeline for us and our team. So thus, the gtSummary package was born. We started writing it a couple of years ago, and we started internally within the hospital, like behind our firewall. No one else had access to it. And we just started writing these functions that were helpful for us, some things that we knew that we needed that would help us meet that goal of a 100% reproducible workflow. And it worked out so well for us, and it was so useful for us that we decided to actually make it external and submit it to CRAN. And since it's gone public, it's actually gotten so much better because of far more users are using it, requesting support for various models and various features that we incorporate. And overall, the product, the final product, well, not exactly final, it's still ongoing, has been greatly improved by the community. It's been amazing. So let's just talk about what you can do with gtSummary. So essentially, gtSummary is going to focus on creating summary tables. And just tables. That's all we do. We can create table 1 type tables. This table 1 is often the first table that you report in a research article in medical research describing your cohort. We can do cross tabulations. We can summarize regression models, summarize survival data, competing risks data as well. If you work with survey data, that's also included. And there's a lot of customization available here as well. And that was something that was quite important to us when we wanted to. We wanted the defaults to be quite sensible, but we also wanted the users to be able to customize it as needed to get exactly what they needed so that they could meet their 100% reproducible workflow goals as well. In addition to just creating these tables, we are often in our reports reporting the results from our tables in the text of our reports. So we wanted to be able to have some kind of mechanism where we could easily report results from our tables inside the R Markdown reports. And so each one of these table types that we're going to talk about they are oftentimes alone exactly what you need to report, but sometimes they're not exactly what you need to report, and you need to and we treat them more like as the building blocks of the larger table that you may need. And to that end, we have ways you can stack and merge any gtSummary table with any other gtSummary table as well. Later on, near the end of the presentation, we're going to talk about themes and how they're a wonderful way for you to make a huge number of changes to the defaults at one time. And we'll also talk about print engines at the end as well. So a bit about the data set we're going to be using. So within the gtSummary package, there's a data set called trial. It's just simulated fake data where there are 200 patients who received drug A or drug B. In this data frame, each of the columns have already been assigned a label using the labeled package. So while the column is called TRT, there's also an attribute label that's going to be, I believe it's chemotherapy treatment. And each one of the variables has that. And that's going to be important, as you'll see later here. I recommend, if you don't label your data, I highly recommend that you do. It's quite helpful, especially when you return to your data after some time away from it and you've kind of forgotten what all these abbreviated column names can be. As our motivating example, we're going to take a smaller subset of the trial data set. We're going to call it SM trial or small trial. And it's just going to be the TRT, the chemotherapy treatments the patients received, drug A or drug B, the patient's age, their tumor grade, and then lastly, the outcome, did their tumor respond to the treatments? So those are the 4 variables we're going to focus on primarily throughout this presentation. So let's start with TBL summary. TBL summary is a great way to summarize a data frame. So here on the left, you can see here that we are piping the SM trial, the small trial data set. We're removing the treatment variable because that's going to come back later for us. And then we're just piping that data set straight into TBL summary. So essentially, we have like a single line of code where you're passing a data frame into TBL summary, and you're getting a pretty wonderful, in my opinion, summary of the data. You can see here that age was automatically detected to be continuous. So it says, okay, well, this looks like a continuous variable to me. I'm going to report the median and the IQR for it. And it can see that it has 11 unknown values or missing values, and it reports that as well. Similarly, it sees grade as a categorical variable and reports those for us as well. And lastly, tumor response. Tumor response is a dichotomous variable or binary variable. Variables in gtsummary that are coded as true or false, yes or no, and 0 and 1 are detected to be dichotomous, and they're reported on a single line because you often only just need a single line to report these values. So you can see here we have a continuous, we have a categorical data, and we have dichotomous data. But on the right, on the left here, you see there's another continuous type called continuous 2, and we'll get to that in a moment. And you can see here that the label attributes, age, grade, and tumor response have been already automatically applied to the data set, which is a really nice feature of these functions within gtsummary. If you didn't have label attributes, it would just print the column name. And of course, there's functionality to update the labels within the TBL summary function and all the functions within gtsummary. All right, so while this is a lovely table, let's make it a little bit more complicated, customize it a bit. Again, we're going to start with our small trial data set. And instead of removing the treatment variable, we're going to start by saying, I want to see my summary statistics by the treatment that the patients received.
Hey, Daniel, we had a quick question in the chat. What were the selected variables for SM_trial again?
They are treatment that the patient received, patient age, the grade of the patient's tumor, and then whether or not the patient responded to the treatment. So it's a 0-1 variable in the data set.
Thank you.
No problem. Yeah, please feel free to continue to ask questions. I like it when it's more interactive, but especially with these virtual meetups where you're just talking to your screen, looking at your own slides, and you don't know if anyone's on the other side. So appreciate questions. All right, so back to our example here. So instead of removing the treatment variable from the data frame before passing it to TBL summary, we're telling it TBL summary, we want to see the summary statistics by the treatment that the patients received, which is a very common thing we do in medical research. And instead of using the default type of age being continuous, I'm telling it I want it to be continuous 2. Continuous 2 is a continuous summary that appears on 2 or more lines in the resulting table. And that leads us to the statistics argument, where instead of using the default median and the IQR, you can specify various other statistics. So let's look at age first. So you can see here, age is now being requested to do a mean and a standard deviation. And then on the next line, a min and a max. So if you're familiar with the glue package from RStudio and the tidyverse, this may be intuitive to you, the syntax, and if you haven't, it may be somewhat less intuitive. So the glue package, it takes strings as inputs, but anything inside curly brackets, it wants to evaluate that for you and replace whatever is in those curly brackets with the value. So similarly here, we are passing in the curly brackets mean. So what's happening in the background here is that gtsummary is looking for a function called mean, and then it's going to take the variable age, it's going to calculate the mean, and it's going to drop into those curly brackets the mean of age. And it's going to continue to do the same thing for the standard deviation, which is next, SD. So you can see here that we have mean, and then in parentheses, we have the standard deviation, which is exactly what we're seeing here on the right side as well. The min, comma, max has been recognized as the range, so the label here has been updated to be the range. And we've also decided to report for tumor response, not just the n in percent, but the n with the denominator and the percent there too. So there are various ways to report these kind of statistics.
Daniel, there's a question in the
yes.
chat. Can the standard deviation be replaced with standard error?
Yeah, you can actually put any function in those curly brackets, and that includes user-defined functions. So literally anything that takes a vector of numeric vector and returns a single number, any of those functions that meet those criteria can be used in the place of mean or standard deviation, for example.
Now, this is my question. So
yes,
with the mean and the max, you mentioned it recognized it's the range. So it seems that automatically put it as range. Is there some sort of way where we can actually have min max written there?
Yeah, absolutely. You can change the what's being shown here quite easily with some modify family of functions that we will visit in quite a few slides. Actually, they're a little bit further along. But yes, pretty much anything can be changed.
Thank you.
So you may recall from the previous table that age was rounded to the nearest integer. Now, so in addition to recognizing that age is a continuous variable, one important thing that it needs to also do is decide how many digits to round the output to. So in this case, what we do is we look at the spread of the variable, and if the variable goes from 0 to 10,000, we're not going to look at that range and say that we need to have the mean to 5 decimal places. That would be quite excessive. So what we do is we take a look at the spread and we make our best guess to what would be a reasonable number of digits to round our results to. Now, again, that can be changed. So while the default for age was to report the statistics to the nearest integer, we are here with the digits argument requesting that the age variables round things to 1 decimal place instead of to the nearest integer. So these are kind of the basic syntaxes you'll see throughout the gtsummary package. You will see that there's pretty heavily we're using formula syntax. So quite generally, on the left-hand side of the formula, you are going to select a variable, and on the right-hand side of the formula, you're going to give instructions on what to do to those variables that you selected on the left-hand side. So minimally, you can just put age, like you see in the first example here. And on the right-hand side, you see age, I want you to display patient age for the label. So that would update the label from just saying age to saying patient age. You can select variables using vector notation. So you can see here under the type argument that we can see that we're going to do both age and marker, and we want them to be a continuous variable if they were perhaps not that by default. You're also able to use any of the tidy select selectors available throughout the tidyverse, dplyr, the tidyselect package with gtsummary. So in the digits argument example here, we're saying anything that starts with age, which is in this case, the only variable that starts with age is age. So take all the variables that start with age, and I want to round them to the nearest integer, to 0 decimal places. Now, gtsummary also comes with a bunch of internal selectors as well that are specific to gtsummary tables, such as all continuous. And you can see here that I am using all continuous on the left-hand side to select every continuous summary statistic, or every variable that's being summarized continuously on the left-hand side. And on the right-hand side, I'm saying, take all my continuous variables and I want to report the mean and the standard deviation rather than the default mean, median, IQR. And in case there are multiple instructions that you need to pass, you can just drop these formulas into a list as well. You can also just use named lists, but with one limitation is that the named lists cannot use the selectors. They can't use all continuous, they can't use starts with, they can't use the vector selector. It would just have to be, for this example on the bottom of the slide, it would be the list, age equals patient age, comma, marker equals marker level. So that would be a way to use named lists. Named lists can actually be quite helpful when you're applying like the labels, and you can save a vector or a list of the variable labels you want to use if you're not the kind of person who likes to label your data frames. So yeah, this syntax is quite important to become familiar with within the gtsummary package. So within gtsummary, there are a bunch of add-on functions. So anything that starts with add underscore is typically going to be something that's going to add additional information or additional statistics or columns to your current table. So this would include, we have an add p function for adding p-values to compare values across the TBL summary table. You can do Q values for corrected p-values for multiple corrections. You can add overall statistics when your table has been split by treatment, for example. You can also report overall. And you can also look at treatment differences, and you can also add like the number of observations. There are more functions, and you should check out the website to see them all, but those are the most commonly used ones, I feel. The modify family, so every function that starts with modify, these are functions that are designed to update or modify the aesthetics of your table. So this would be things like the column headers, spanning headers, footnotes, source notes, captions, and actually other things like bolding, indenting, italicizing. There's a few things within gtsummary that we have allowed to be modified that way. And then we do have a couple specialty functions which wrap some of the modify functions but make it a little bit easier to use. Bold and italicize, and these will like style the labels, the variable levels. You can bold significant p-values, for example. So let's go check out a few examples using these functions.
Daniel, one quick question.
Yes.
Is there, here we have on the chat, is there a way to specify units like age in months for a pediatric trial? So
yeah, so for example, here on this bottom here, if you wanted to say age, comma, years, you could put that right here in the label. And for the marker, you could put marker level, comma, nanograms per milliliter, or whatever it was.
Great, thank you.
Thanks. All right, so let's update our TBL summary table with some adding functions. So let's start again from the very beginning, taking our small trial data set, piping it into TBL summary. We are splitting our summary statistics by the treatment the patients received, and we're adding a p-value comparing the values. So let's look at the p-value column first. So what this p-value is comparing, depending on the test, so check out the footnote. You can see here that the footnote says it's the Wilcox and Ring sum test. So we're comparing the distributions of age between treatment A and treatment B. And you can see we don't have a significant p-value in this case. And continuing down, you can see that this is a categorical variable. Of course, you can't do a Wilcoxon rank sum test on a categorical variable. As you can see in the footnote, it was Pearson's chi-square test was used. Similarly for tumor response. So this is a function that has lots and lots and lots of different tests you can specify. And there's a help file that lists every single test that you can run. And it also shows you the functions that are being run in the background. And I think that's one of the most important things, because we really wanted to make it very clear to the users exactly what we're doing and how we're doing it, because various fields use various language for different tests. And so I think it's really important that the user can look up and say, oh, when he says t-test, he means t-test with the continuity correction, excuse me, assuming equal variances or not assuming equal variances. You can look at that help file to see exactly what we mean. All right. And all right, let's take a look at, after the add P, we pipe this into add Q to do a correction for multiple testing. Probably not needed in a table with 3 P values, but it's illustrative. And in this example, we are using the Bonferroni correction. And what's happening in the background is that we're using the base R function p.adjust. And if you were running this interactively in your console, we would actually print right into the console, hey, we're using p.adjust with this method with the p values. That's how we're calculating your adjusted p values. And again, I think that messaging is incredibly important and one of the big benefits of the package. All right, let us show another example. This is one of my favorite new-ish functions called add difference. One thing that we're constantly doing, and especially in randomized trials or other studies comparing two treatments, is that you want to look at the outcomes for the two groups, but what you're particularly interested in is the difference between the two. So we are, again, just taking we're actually using a larger data set this time. So the full trial data set, making a subset selection using it for treat, marker, and response. And we are summarizing our results by the treatment again. We are showing the mean and the standard deviation like we've seen before. For response, we only want the response rate because we don't want the ends in front kind of mucking it up. We want it to be very clear, like 29% in drug A responded to treatment and 34% in group B responded to treatment. The difference, -4.2. And then we add the confidence interval for that difference with the p-value. And of course, again, for clarity's sake, the footnotes are quite illustrative to what, quite clear what tests were run here. So that's good. Any questions on add P, add difference, add Q? So add difference is, this is something that Malcolm helped us out recently with by adding standardized mean differences. And it was a wonderful contribution. So thank you, Malcolm. All right, let us continue with two more examples of the add family of functions. So pretty much the same old TBL summary that you've seen before, split by treatment. And this time we're using add overall to add this column of the overall statistics. So this is saying, okay, well, overall in your cohort, the median age was 47. And then by each treatment, it was 46 and 48. So that's what that does, adds that whole column. Add n adds a column of n. You can see here that in the TBL summary call, I said missing equals no. So you'll notice that below age, we no longer have that row for the number of unknown because we said, don't show me the number of unknown. In this case, I prefer to use add n to show the number of non-missing observations. And within add n, you can report percentages missing, percentages not missing, n's missing, non-missing. There's a lot of options for customizability in there as well. Pablo, I think this was your question. Can you change the label for range? And I believe that's possible within the add stat label function, actually. So you'll see here that there's no footnote saying I'm using median IQR and an n%, because what we're seeing here in the add stat label here is it appended the statistics that are being presented to the variables. So we have age, comma, median IQR, and then we're using this label argument here to say, instead of just n%, it's saying no period, and then percent in parenthesis, and you can see that that precise label is being used here. Otherwise, if you didn't add that argument, it would just be the default footnote that we saw in the previous tables. Where it is? There it is, with footnote 1.
Perfect, yeah.
Okay. All right, and lastly, the last add function we're going to talk about is a very general function called addstat. Addstat is, truthfully, it's an internal function that's used often throughout the internals to create the function as the engine that powers the functions we've just reviewed. But this is a very general function where you can essentially pass a function to calculate any statistic you want, format it any way you like, and we can easily add that onto your gtsummary table. So in this case, instead of reporting a p-value alone, we decided to report the t-statistic, a comma, and a p-value. Not something I've ever really needed in real life, but you can really do anything you want there. Some examples of italicizing and bolding. Again, we're going to go back to our trusty old basic table here, and we are bolding the labels. So you can see age, grade, and tumor response are now all bold. We are italicizing the levels. So the unknown level of age and the grade 1, 2, 3, and tumor response unknown, they're all italicized now. And we are now bolding significant p-values. Now, the threshold by default is 0.05, but because in this example there are no significant differences, I had to bump the threshold to 0.8 to illustrate what it actually does. So a couple of things that you can do. Knowing that it's possible is more than half the battle, right? Okay, let's move into the modify family of functions. Before we discuss the details, I just want to say that every modify family function can be applied to any gtsummary table, not just a TBL summary. Of course, some of those add functions were very specific to TBL summaries, but modify, it goes for any table within the gtsummary package. So let's start here with our basic TBL summary that you've seen before, and I'm assuming you love. We're going to use the function modify header to change the header. So previously it had drug A, drug B with the number of patients within each group, but this time we just want to see A and B. So we say update, I want stat 1 to be A, stat 2 to be B. We're using the stars as the markdown syntax for bolding A and B. Stat 1 and stat 2 are the underlying names of the data frame that's being printed. So you're probably wondering, well, how am I supposed to know that? That's a good question. There's a function that called show header names. So if you pipe your gtsummary table into show header names, it will show you each of the columns, what the current header label is, and then what the underlying column name is as well. And so that will get you the information that you need. So here we're using modify spanning header to add a spanning header above the treatment. To do that, we are using this other selector from the gtsummary package called all stat calls. So you can see here that this is called stat 1, stat 2. So what it's doing is it's selecting all of those functions that start with stat and end with a number. And it's saying above all of those columns, I would like to put a header called drug. And again, the stars are markdown syntax for bolding. And here I am replacing the default footnote that says simply median IQR colon n% with median IQR for continuous and n% for categorical variables. So just an example that you can update your headers, spanning headers, footnotes, and like I said, more. There are other modify functions that are quite helpful to use as well. So I definitely recommend you check out the reference page on the website. And there is also a detailed vignette for TBL summary that goes over lots of what you saw here, but additionally a lot more as well. There's another summary function called TBL Cross. Now TBL Cross is a wrapper for TBL summary, but it gives you the results in a very specific format as a cross table. So in this case, we're taking our trial data set. We're saying, I want to look at treatment and grade, and I want to see the ends and percents. So you can look at row percents, column percents, no percents. You can add row margins, column margins, both, no margins. So you can see here that we have a margin row. So we have an additional row for the total margin. That's the sum over the grades. And then you also have everything stratified by drug A, drug B. Just like TBL Summary, it has a method called addP, where you can make comparisons of these two variables. And here I'm using the source node equals true, indicating that I would like the p-value placed in as a source node rather than as a new column like it is in TBL Summary. This is a brand new function from the most recent release called TBL Continuous, and you can summarize continuous variables by one, two, or more categorical variables. So here you can see that I'm using my small data set, my small trial data set. I want to summarize, oh, looks like I have a typo here. I apologize. I want to summarize the variable age by treatment and by grade. So you can see here we have median IQR of age within each grade and treatment combination. So you can have as many variables as you want along the rows, and you can calculate this with or without by treatment column as well. So this one's been quite helpful already for me, which is good. If you work with survey data, we essentially have a clone of TBL Summary called TBL Survey Summary, and pretty much everything you did previously with TBL Summary, you can do with TBL Survey Summary. The difference is that it's a little bit more restricted in what summary statistics you can request, because we can only do the summary statistics available to us within the survey package, because they need to be calculated quite specially.
Daniel, one quick question from the chat. From Eva, hi, can I use a labeled text with characters in sub or superscript, like the number 2 in meter squared or?
Yeah, you can do that. I think that we have an example of that coming up, but it depends on the output type that you're looking for. So gtsummary, the GT stands for GT, which is this package from RStudio that is actually making all these tables, printing all these tables. Which I forgot to mention in the beginning. This is pretty important, I guess. So depending on the output format, you can sometimes just, Google like an uppercase 2 or from your Word document and just place it right into your label or, wherever you want it to go, and it will just work with no problem. Sometimes you have to use the UTF-8 code for it, but yes, you can do that. Thank you for that question. So the last summary of raw data that we want to show you today is called TBL Surfit. So if you work with time to event data, I work at a cancer hospital, and we are always looking at time to recurrence and time to progression and time sometimes to death, depending on the disease and the progression of the disease. So summarizing time to event data is something that we do all the time. Now, to be honest with you, I don't often use this table for publications. What I most often do is I will describe survival visually, and then I'll use that same Surfit object, and I'll pass it to TBL Surfit to give me a table with some time points of interest here. And then I will use those inline features that we spoke about previously, very, very briefly in the introduction. We'll go more into it in a bit, so that I can report these numbers in the text of my reports. So that's primarily how I use this, but you can see here the TBL Surfit also has a method for addP, and if you are presenting this in your manuscripts, you can use these labels to make it cute. Instead, like I think the default is to say time 12, time 24, but you can just say time, and it will it'll add the time here for you, and then month. So now we're looking at 12 month, 24 month. Much more nice to read. All right, any questions on data frame or data summaries before we move on to regression models?
Let's see, we have a couple. Well, let me go for the question from Rebekah first. It says, hey, is there a way to run R code in a header? Example given, you can access N from a gtSummary object and do modify underscore header results from N patients, but is there a way to do something like modify header? Oh, this is a this is a little bit of a difficult question. Do you have access to the chat, Daniel?
Yeah, let me take a look. Is there a way to run R code in the header? You can access N from G. So yeah, you can access the N. Yep. Is that we do something like results from. Oh no, we don't actually do that. Let me think. No, that would not be possible. So essentially what's happening in the background is we have a small tibble with every column, like one row for every column in your data set. And then we have statistics like N, the percent, whatever. And then we're using the glue data function to take whatever you pass to modify header. So for example, in here, we would take this string that has in curly brackets the N, and from that data frame, we would replace the N with the column N and that value, and then put that into your table header. But this would be something more complicated. And if you're doing these kinds of calculations, you can do them right before your TBL summary, and then whatever result that is, you can plop that right into the modify header. But there's not a way to access it like that with the with that kind of markdown syntax was saying, like, you know, what is that? A tick mark R, I'm doing R code now. We don't have ability to do that, unfortunately.
Thank you.
Yeah, the slide deck is available on my GitHub right now, by the way. So, and there'll be I think I show my GitHub name at the end of the presentation. So yes, it is there ready for you to watch again and again and again and again, I hope. All right. So I love data summaries, but I'll tell you, I feel like one of the biggest strengths of the package is its ability to summarize regression models. You know, if you do regression often like I do, you'll know that in R, the summaries you get in the console, they're messy. It's not easy to read. It's not easy to interpret oftentimes. You know, you can see here that, you know, we here on the left, we're building a logistic regression model. So we're using the GLM function where tumor responses are outcome, and we're using age and stage to predict patient response from the trial data set. And then we're using this family equals binomial to indicate that we're doing the logistic regression, so a binary outcome. And then these are the result you're seeing on the right is from the summary of M1, our model. So here, you know, typically in a logistic regression, you don't care about what the estimate is, or what they call the estimate, the slope coefficient. What you want is the exponentiated slope coefficient, or the odds ratio. So a lot of these numbers aren't really that helpful to look at. And again, as you know, reading our console output can often be difficult. So we wanted to make this very easy and very nice to get a beautiful summary of a table. And I think that TBL regression does just that. So again, this is a single function call with one argument, the model object M1. And for me, I think you get fantastic summary. So you can see here that the model was automatically recognized as a logistic regression model. And so instead of just putting a beta up here, it says, oh, you're looking at the log odds ratio, the log OR. And so we can see that the log OR for age is 0.02, and it has a confidence interval from 0 to 0.04, and a p-value of 0.091. And similarly for stage, you can see all those estimates. And one of the best things here is that it can see that stage is a categorical variable. So it can detect that, and it can also find your reference level. So if you're using various contrasts where your reference level is not T1, it might be T3 or whatever you've chosen, it's going to recognize that as well. So whatever your reference category is, it can detect it and it can add it to your table. And this is one of the things that I was always futzing with when I was building my markdown reports before gtsummary, because I never could get that reference row. So for me, in my research, in the way that we report, this is just super, super helpful. And above and beyond that, since we have the OR up here and the 95% CI, we do have footnotes to make it very clear exactly what you're looking at. So seriously, one function, one argument, and you've got a really great table. But it's not exactly how you would report it, because like we said, you want the odds ratio. So let's do a little bit of customization here. So now this time we have our TBL regression function. We're again just passing the model object, our logistic regression model. And this time we're saying exponentiate equals true. And so that's what we want. We want to exponentiate our coefficients. And now you can see that TBL regression has automatically identified this again as a logistic regression, saw that you're exponentiating, and updated our header to be an OR instead of the log OR. Our next function here, add global P, what that is doing is previously you had a p-value for every level of stage in reference to T1, right? But sometimes that's not what you need. Sometimes the question is, what is the significance of stage? And so you just need a variable for stage, one p-value for stage. And so that's what add global P does. And again, if you were running this interactively and you ran add global P, it would print the exact code it was using to calculate the this global p-value, and it's using the car package's ANOVA function, which is super, super useful. If you're familiar with the broom package from the tidy models verse, you'll know that you'll often see functions called tidy, glance, and augment when working with regression model objects. So glance is if you pass the model object to the function glance in the broom package, it gives you a tibble back with a bunch of statistics in one row about your model. So things like the number of observations, the log likelihood statistics, the AIC, the BIC, and pseudo R squared, and many, many more things depending on the type of model you're working with. So we have this function called add glance table to add those glance statistics to your table. So those have been appended here at the bottom. We also have a function called add glance source note, which adds the same statistics as a source note instead of making your table very, very long. So I think this is really easy way to get a super, super useful table. And there are lots of models supported. I actually didn't I stole this slide from a presentation I gave, quite some time ago. And this list is now longer. And the number of supported modeling objects is it's growing all the time, as someone will say, hey, I'm using this very esoteric package, but it doesn't work. And then we can make it work usually. And even if so like I said previously, the broom package comes with these functions tidy, glance, and augment. We are using the broom tidy functions heavily, very, very heavily. So if broom doesn't have a tidier for your model object, you can still use gtsummary, but you may have to write the tidier yourself. Which is typically not that hard to do, but it just expects a format that's pretty standard across them. So you could run tidy on a linear regression model, just take a look at the output, and you would be very familiar with what you needed to pass a tidy function. So if you wrote your own tidier function for a very esoteric modeling package, you could pass your own tidier in the tidy fun argument to TBL regression, and voila, your very funny model is now supported as well. So in addition to doing those multivariable models like we've been looking at, you can also create a series of univariate regression tables, and with the function TBL UV regression. So how this works is that you pass the function a data frame, and you tell it the method, I want to do a GLM. You give it the outcome, I want to predict response. So we're doing logistic regression here again. The method args are passed as a named list. So previously we were running GLM with the argument family equals binomial. And this time we do method.args list family equals binomial. And again here, the other arguments are just the same, exponentiate equals true. And with this function call, you get a series of univariate regression models presented and stacked for you. So you can see up here, up on top, chemotherapy, there's 193 non-missing observations that were included in this model. Odds ratio for drug B is 1.21 compared to drug A. Similarly, you're getting the model results for age, and you can see that the number of observations included is different because each one of these univariate regression models is estimated independently from one another. And there are other functions that we're working with TBL summary and also TBL regression objects that also work with TBL UV regression. Like, so all of your bolding functions, italicizing, all of your modify functions, add global P, and others, they all work with UV regression tables as well to make it easy to make some very cute tables. All right, anything on regression model summaries before we move on to the next topic?
No,
Okay.
no questions in the chat.
All right, so now, no, I've alluded to this a couple times in our presentation. So we're going to talk about a function called inline text. And like I said previously, oftentimes you create these summary tables, and what you need to do to have an entirely reproducible report is you need to report those results in the text of your markdown document, but you don't want to hard code them because sometimes you have to rerun your analysis after you exclude one patient, and then you don't have to go through the entire text of your report to change every single number. If you use the inline text feature, you'll never have to do that. So we're going to look at examples with inline text using regression model results, but this can be used with any function with gtsummary. So the inline text here, what we're going to go through is an example where we're going to report the results from our logistic regression model. And so the inline text method for TBL regression objects has an argument called pattern. And the default pattern is to report the estimate, in our case, the odds ratio. Then it reports the confidence interval in parentheses, and then also the p-value. And so that's what you can see here on the screen. And of course, because this is just the default, you can change this to be whatever you'd like it to be. Okay, so a quick reminder what that table looked like, our univariate regression table. So what you would write in your R Markdown document, in the body of it, you would say the odds ratio for age is, and then this is supposed to be a backtick, but it's formatted a little bit funny for this presentation. And you say backtick R, and then that says, hey, I'm going to be running some R code right here. And you say inline text, you pass the TBL UV reg object that we created earlier, and you say variable age. So what that's going to do, it's going to say, okay, this is my TBL UV reg object that I created, and this is my variable age. And so then it's going to go through here, and it's going to use the pattern to extract the odds ratio, the confidence interval, and the p-value. And when you render your report, it's going to say the odds ratio for age is 1.02, and in parentheses, 95% CI is 1 to 1.04, and the p-value is 0.10. So that's a super, super useful way to make the text in your report reproducible, as well as your tables and figures. All right, so we have lots of kind of data summaries and regression model summaries that we've discussed. And sometimes you need to combine them. Sometimes you need to combine multiple regression types together to be side by side. You can do that with TBL merge, or to put them on top of one another, like TBL stack. Sometimes you need a summary table with some summary statistics about about anything, I guess, and you want it side by side with your regression models. So those are things you can do with TBL merge and TBL stack. It really makes all of these tables building blocks for what you need in the end. So we are going to use TBL merge for our example, where we're going to put a univariable table and a multivariable table side by side. So as we've seen before, on the left-hand side here is our code to create a univariate regression table. This time we're using method coxph from the survival package, and our outcome is a more complicated object than just a single variable. It's the bivariate time to death and the status of death. And here we're going to be exponentiating our results again so that we get the hazard ratios. And then we're going to be adding our global p-values. Now, very similarly, on the right-hand side, we're going to be building a multivariable Cox model with the same outcome. And this time, the multivariable model is going to include the two variables, age and grade, at the same time, which is different, of course, from the other side, which one we are doing univariately. And we're going to pipe that to TBL regression, the same exponentiate equals true, and the same global p-value. And let's see what we can do with that. So here's what our tables look like. So two tables that kind of sit independently from one another, not what I want. I want, because we're duplicating the first column in each table, and there's no need to do that. So if I put both of these these gtsummary tables into a list, and that list is the first argument of TBL merge, I can optionally include the tab spanner to say, well, under the first set of results, please put the header univariable, and under the next set of results from the second table I'm passing that I'm merging, please put multivariable, and you will get this, what I feel is a very beautiful merged table. All right. Do we have a question here?
Yes.
Can we add parentheses? Oh, sorry.
No, go ahead. No, go ahead.
All right. All right. Can we add parentheses around the confidence intervals? Yeah, absolutely. You can. We'll actually go into an example pretty soon about how there's one way you can do that, but you can absolutely do that. And another question from Ava: how do you customize the font size of the tables? There are a couple ways to do that, and we will get there. And I think they're really useful tools for us to have. So I look forward to sharing that with you. Okay, I'm smiling about it too, Ava. All right, so we just did a TBL merge, and now I want to show you TBL stack. So in this case, I want to have an unadjusted model, so a univariate table. So I have a Cox regression model here with just a single predictor treatment, right? And it's predicting the time to death of the patients. And so I'm doing a couple things here differently. I'm piping this regression model object to TBL regression, and I'm using this argument called show single row. So in our previous tables, when we had treatment, we had one row that said chemotherapy treatment. Then below that, indented, it said treatment A. And then below that, it said treatment B. And then treatment B had the odds ratio, or I guess the hazard ratio. So in this case, you have a variable, a binary variable that's taking up 3 rows in your data, but you really only have 1 row of statistics to report. So show single row is a way that you can take those binary variables, and instead of putting them on 3 rows, you can put them on a single row. I am updating the label for treatment, which is defaulted again to just be chemotherapy treatment. So I need to say, instead of just saying chemotherapy treatment, I need to say, this is drug B versus drug A. And drug A in this case is our reference group. And again, we want to exponentiate the results. So we put exponentiate equals true. So again, this is a univariate regression model. And here we're going to have an adjusted model. So we have the same outcome, same Cox regression model, except for we have treatment, but adjusted for grade, stage, and marker. And we put in the same arguments here, but we've added this additional argument called include. So it's not uncommon that you will have a large multivariable model, but the thing is you're only interested in 1 or 2 of those variables in the model. So in this case, let's say that we're experimenting and we want to know, is drug A better than drug B? So that's the only thing we care about. We already know by decades of experience that grade and stage predict the outcomes of these patients. So that's not informative to waste space reporting the odds ratios for every single stage and every single grade. So therefore, we can just say include treat, which will say, okay, well, I know I have 4 variables in this model, but please only include the results from treat in the resulting table. So here's what our tables look like. You can see the hazard ratios are just a little bit different because one is unadjusted and one is adjusted. And we will use TBL Stack to stack these on top of one another. So here we are again. Again, you just put the tables, the gtsummary tables, into a list. and they will be stacked. And we're using this argument group header to add these unadjusted and adjusted headers. If you didn't add that, you would just have two rows that pretty much looked identical. There would be no way to identify which one was adjusted and which one was unadjusted. So that's why we decided to add those group headers here. Is there a way to we have a question from Rebekah. Is there a way to programmatically select all variables with two levels for show single row? Yeah, it's exactly all dichotomous. Exactly. Thank you, Malcolm. Another table another function I want to show you is TBL Strata. So this TBL Strata is a fantastic function, and it works on any gtSummary table where the first argument for that function is either a data frame or a survey object. And this is just a very simple way to create multiple gtSummary tables stratified by a variable, or actually you can put as many variables as you want, actually. And it will calculate all the summary statistics stratified within those groups, and then at the end it will merge them all together. You can, that's merging is the default. You can also say please stack them instead. That's also an option. The syntax here I think is pretty nice. So you pipe in a data set to TBL Strata, you tell the function my stratification variable is grade, and then you're going to recognize this syntax if you love per maps from the tidyverse, which I love per maps a lot. So you put a tilde indicating that this is an anonymous function. And then .x represents that stratified data frame in this case. So it's the data frame for only the grade 1 or only the grade 2 or only the grade 3 patients. And then from there, the syntax is exactly the same. I want to see something by treatment. I don't want to show missing values. I'm using modify header to say, instead of showing me the n in percent for all of these things, because that would be instead of showing me the level and the number of patients within that group for all 3 of these 6 groups, just show me the level, because if it was showing me everything, it would be way too long or way too wide. So I'm using all stat calls to select all of the statistics column, and I'm saying, please replace it with the level. And again, I use the double stars here for bolding. Okay. We have a question. Great. So that's how you use TBL Strata. It's a function that will definitely come in handy as you build your tables here. So I wanted to show you one example of how you can put all of these tools together. So there was a group who reached out to me on Twitter, or maybe, no, I think it was on GitHub, and they said, oh, we love the package. It's super useful. We appreciate it a lot. We are constantly reporting odds ratios and Cochrane-Mental-Hansel odds ratios from stratified, from the stratified and then combined to be the Cochrane-Mental-Hansel. It's been a long time since I took EPI. Wow. So they said, can you build a tabling function that makes this table for us? And I didn't think that this was a table that fit well with the goals of gtSummary. But what I was able to do with them was use these tools that we've been talking about to stack and merge and add custom statistics to summary tables to be able to construct this pretty easily. So the most basic table we're looking at here is in orange. It's TBL Cross. So we're just looking at exposed, not exposed for the control group. And we're looking at it by T stage. So that's a TBL Cross. We can use TBL merge to merge the cases and control data. Then we can use add stat to add these custom odds ratios and the CMH odds ratio and the p-value as well. And once you've built that table, you can just use TBL Stack to stack it all together. So we have a somewhat complicated table here, TBL CMH, but the individual parts are not so difficult to construct. And so now this function can live in their own personal or department package, our package. And the benefit of this is that it's still a gtSummary table, which means you can still report any of the results in line. You can use any of the modify functions to change the aesthetics. You can use the bold and italicize as well, and various other things that we're going to talk about shortly. So yeah, this is a really helpful. And I actually have a couple of these that we will look at. I think I added a couple slides for some tabling functions that I have outside of gtsummary as well. So next we're going to talk about the themes. Themes are one of my favorite things that I think are somewhat underutilized, but that's okay. So a theme in gtsummary is a way that you can customize a lot of the preferences, and you can easily reuse them. So they control a lot of the default reporting, and they offer you control over a lot of really fine-grained customization that are not even available to do via the arguments or any of the other functions available. And so you can use some of the available themes that we have in the gtsummary package, or you can create your own. And depending on how generalizable your personal template is, we can add it to the package as well. So let's just start by taking a look at the default output for a regression model. So this is the same logistic regression model we've been looking at and loving, I guess, for the last 40 minutes or so. And so here, I'm just adding the caption here that this is the default theme. This is our default output. But this may not be how you report it in your field or whatever. So we have themes. So the first function I wanted to show you for theming is called theme gtsummary journal. And so if you specify, I put this reset theme here because you can delete all of the themes. But if we use this theme function, theme gtsummary journal, specify the journal as JAMA. So if you are submitting to JAMA, or if you just love the way JAMA reports their regression models, then you put this at the top of your script and you summarize TBL regression, and which is exactly the same code that you saw previously. And we're doing modify caption instead of calling it default. We call it the journal theme JAMA. And you can immediately see a few differences here. So while previously we had a column for odds ratio and a column for the confidence interval, you can see that they've been merged into a single column. And the confidence interval is in a parentheses. And instead of having a comma between the upper and lower bounds of the confidence intervals, we have the word to. So that is how JAMA does it. You can also see that the p-values, well, typically large p-values in gtsummary are rounded to 1 decimal place. So this would be like 0.6. JAMA likes it all the large p-values rounded to 2 decimal places, and the small ones still get more significant figures, but the large ones get 2. And so you can see that we're doing 2 decimal places here. There are differences in the TBL summary results as well. For example, JAMA doesn't put the percent sign next to their percentage. So they kind of just put N and the parentheses, the percent, but there's no percent sign. So that will be your default output from TBL summary. So this is so nice. We support, we have, let me think. So we have the New England Journal of Medicine, we have JAMA, we have Lancet. I think we have another journal from psychiatry, and then also like an economics journal, I believe. And those are the journal themes. So if none of those really fit your needs, and you submit for your field and the journals that you submit to, just let's have a conversation. We can definitely add what you need for your journals. Of course it's best if your journal, like the top journal in your field, has reporting guidelines that we can mimic. But if they don't have that, it's also possible just to go review some of their top papers and see how they prefer to report. Oh, and we also have a theme for exploratory data analysis. And what that one does is it reports more statistics by default. So for example, in TBL summary, I think you'll get the median IQR, which is default, but then you'll also get the mean and the standard deviation, and also the min and the max, to kind of give you this, maybe that's not something you need to report in every paper because that's a lot of summary statistics, for example, but it will help you get a good idea of your data and what you're working with. In addition to journal themes, we have language themes. I believe there are 14 or 15 supported languages at this point. So here, ZH stands for Chinese and TW for Taiwan. So this is Mandarin. So they use in Taiwan, they're using what do they call it? Traditional characters, excuse me. So you can see here that the person who we were working with to get these translations, they said, leave OR as OR because that's what most people will understand. But you can see the footnote has been updated so that it's OR, and then the explanation of OR is using the traditional characters. So, you know, we have, yeah, like I said, 14, 15 languages supported here, and it's really helpful. I know that, so the reason this feature exists, actually the reason that themes exist at all is because one of our collaborators is in Spain and was suggesting like, hey, we really need a way to produce our results and communicate our results very easily. So what can we do about that? And that's how themes were born, and they've just been fantastic. So someone said something about controlling font size. So the default gtsummary table, let's take a look at it again. It has very wide padding, which I think for looking at a single table is actually quite nice to look at. But the moment I put it into a report or from an R Markdown document, that extra padding is just so big, and every table is taking up its own page, for example. So the compact theme is a way to reduce the padding, reduce the font size, and just make your table a little bit more aesthetically pleasing, I feel, when you have rendered documents. So that's one way to control font size, and we will talk about other ways as well a little bit further down the line. So like most things in gtsummary, we have one question here. Is median absolute deviation and similar a predefined field, or do I need to calculate it first and substitute it manually? Honestly, I have never used the median absolute deviation. So, so if there's a function that will calculate it for you, we're talking TBL summary, right? Anyone? I can't even.
Yes.
Thank you. So
probably the regression or TBL's regression.
Oh, with TBL regression?
Or
so,
probably univariate first and then regression and
summary.
So
what is the statistics summarizing? What's the median absolute deviation?
You don't want all the summaries in the standard deviation because it tends to underplay the risks. So finance people they always want to know what the absolute worst risk is.
Oh, instead of like a squared variance,
Correct.
It's just like an absolute from the median.
The formula is not too hard. It's just one more
right.
function to put in there for it's discipline specific, Daniel. That's all.
I see. So yeah, is there a math function in base R?
I don't think so. I calculate it
there
myself.
Is.
Oh, is there a math
function? Yep.
Okay.
Oh, okay. So yeah, then in that
Called
case,
math.
you could replace standard deviation, the SD that comes in the curly brackets, with MAD, and then that would get you what you're looking for.
Yep.
Great. So
I can put MAD in the braces directly. Yeah.
Yeah, exactly. And then it will calculate it for you and pop out those summaries for you.
Thank you, and great work on this program on this tool, Daniel.
Hey, thank you very much.
And hopefully the journals will step up and get more of that work done for you too.
Oh my goodness, I would love if they had reporting guidelines, but I would love it even more if they didn't require us to adapt to all of their like very, very minute specifications before submitting to them.
One can dream.
So I was actually a former member of the board of European Urology, and that is one thing that we were able to do. So if you're submitting to European Urology, the top urology journal, by the way, you do not need to format your results to our specifications unless we like your paper. Then you will have to do it for the revision. Or I think actually maybe not even until publication. So before that, we don't even check word counts. We don't check all of these, like you citing this way or that way. I think it's a really huge benefit. Let's see. Fantastic. It works. Using the MAD in the curly brackets. All right, so we've talked about some of the built-in themes. Of course, you can build your own theme. Now, there's an entire vignette about this on the website, and so themes are a little bit tricky to build yourself. Like you can see that to round p-values into decimal places, you have to specify this package-wide function. So package-wide means it applies to all the functions. in the entire package, excuse me. FN means it's I should expect a function, and then p-value fun is like my abbreviation for it. And then you pass a function that styles your p-values to 2 decimal places. Okay, so this is not easy to remember. So whenever you're going to build your own theme, just go to the vignette. It lists them all with descriptions and examples on how to use each of them. So that's the best way to do it. I can't memorize this stuff either, and I wrote it. So this is an example where you can increase, the default number of digits. You can, for every GT table that you create, you can list additional things that you would like to be added to that table. So for every GT summary table you make, if you want to add these tab options, table font size equals small. So this is a custom theme where you're, again, modifying the font size. And in this section, we're adding a tab header with a title and a subtitle. Our subtitle for internal use only, because it's very highly confidential. And just a few other things. We are using row striping. We're not using any of the table lines. We're adding a source note that says the date that the table was created. Just essentially, these are a bunch of GT commands that you can just append to literally every single table. Now, you want to use things that can be added to any table, like specifying a footnote or a source note. That can be added to any table, of course. But if you added a function to say, well, I want to take the p-value and make it blue, well, not every table is going to have a p-value column, so that can screw you up. So be sure in these themes to use formatting that would be available on all of your tables. So using my custom theme, this is what you get in the end. So you have your caption, Acme Corp for internal use only. There's no lines. We have striping, however, which is kind of hard to see on my screen. I don't know if you're picking it up. And then the source note says the table was created on 2021, April 24th. So custom themes. So there's a lot of other options of things you can customize, quite a few. Any questions on themes before we move on? Okay, print engine. So this is one of my favorite parts. I have a lot of favorite parts. So gtsummary, the GT again stands for the GT package. And I love the GT package. I think it's such a wonderful tool. It's created by RStudio. And according to their own documentation, GT is meant to be the grammar of tables, like ggplot is the grammar of graphics. So at this moment, HTML output and GT are just gorgeous and beautiful together. That's why they get a green big happy face on this table. Unfortunately, at the moment, PDF and RTF are currently under construction. Now, with that said, you still can output GT tables to PDF and RTF, and many of the formatting customizations that we add to GT summary tables will be present, but sometimes they're not. I think last time I checked RTF, for example, they don't indent the levels in a TBL summary, for example, but you still get the titles, you still get the bolding, a lot of things. So it's on its way. I'm really excited for when it does finally arrive. I don't know what the word is on support for Word in GT. So at the moment, they just have a no-go, not going to be available. So in addition to GT, there's a bunch of other printers that are available because you may need to go to Word, which is not available in GT. Oh, and Malcolm is saying Word is under construction too, but someone dug a big pit stage. It sounds like RTF and Word output are a messy headache. So if you ever meet Rich, who is the maintainer of GT, tell him thanks, buy him a beer or something. He deserves all of our gratitude because he's working hard on it. So while Word is not supported in GT, you may need it. So what we implemented was the ability to print your tables with all of these various print engines. So you can print tables with GT, with Cable, with Flex Table, with Cable Extra, and Hux Table. And you can also just convert your table to a Tibble, which has benefits, but also, some things that aren't great. So you can see for Cable that we get a bunch of yellow, kind of just like meh faces. Now so Cable tables are nice. They have no indentation. They don't have footnotes. They don't have spanning headers. So you're not going to get the full experience. And I don't think that, no, they do bolding actually. Yes, they do bold. So that's great. Flex Table is my go-to when I need Word output. David Goel, he is the author and maintainer of the FlexTable package, and his stuff just works gorgeously with all Microsoft products. Let me just take a look at this. Oh yeah, Rich is an unsung hero. He absolutely is. He's a really nice guy too, so that's great. So if you're outputting to Word, FlexTable is my go-to. I highly recommend it. If you are very familiar with something like Cable Extra already, that can be a great option for you, because you really should use the stuff that you're most comfortable with, so you don't have to learn an entire new set of syntax and language. HuxTable is a wonderful output format as well, supported by all of the 4 outputs we're showing here. And then Tibble, also good for whatever you may need. I think people often use as Tibble to convert their gtsummary objects to a Tibble, and then they go directly to something like Excel. So they'll like write it to an Excel file. Yes. Okay, this is good. Can we wrap TinyTech around as GT for PDF? So TinyTech is the LaTeX distribution, and please correct me if I'm wrong. These are things that I'm not super well versed in. So TinyTech is the LaTeX distribution that Yihoi wrote for R and R Markdown. And while that is being used in the background by many tabling functions and packages in R as the LaTeX distribution, that's something I feel like is separate from these print engines. That's because that's your LaTeX distribution, which you need installed on your machine. But the TinyTech is a very lightweight, easy to add version of that for us, R Markdown and R Studio users.
Daniel, I've had a question
Yes.
sort of along the lines of this table. I'm just it's sort of a vague question about your future plans for gtsummary and GT. So with GT still sort of maturing, I'm kind of curious if GT's right in the name, right? Of gtsummary. And I'm curious, when GT is to full fruition, and you got big green happy face for all of these, as I'm sure it will be, because again, Rich is an unsung hero, and he'll get it done beautifully. Do you feel that you'll kind of circle back to GT and have that be the primary output again, or do you feel like you're going to continue to support all these other types sort of indefinitely?
Well, it's actually not so hard to support these other types as it is, because the underlying structure of a gtsummary table can, in most cases, be boiled down to, it's a list with 2 things. The first one is a data frame that we're printing as our tables, and then the second one is a list of instructions on how to format that table. So that's like indenting, bolding, various other things. So we don't support that many modifications. So it's not entirely cumbersome to convert this data frame and this set of instructions that's in my own gtsummary language to FlexTable language or to HuxTable language. So the code that we have now will, unless there are breaking changes in the other packages, should just work no problem going forward. So I don't imagine it will be a lot of upkeep. And the same with GT. The GT code as it is now just works. And if you try to go to PDF, there are parts of it that won't work for you. Like you won't get your indenting. This may be like your footnotes may be off-centered, for example, because not all the details have been ironed out. But I would imagine that we just continue to support all of these printing engines.
Cool, thank you.
Great. All right, so now these are great for your R Markdowns, and this is what's kind of running the background of a lot of R Markdown reports, which we'll talk a little bit more about. But I wanted to, and I believe this was Ava's question, how to change the font size. So let's make a simple TBL summary table. So we'll take our trial data set, we'll select age and grade, and just pipe it into TBL summary. So that's what we're looking at right here, right on the right. But I am using this as GT function to convert my gtsummary table. So that gtsummary object, I am now converting it to a GT table. And once it's a GT table, you can use the 100+ functions in GT to style your table in any way you like. So in this example, I'm using cols width to specify exactly how wide I want my label column. I'm using the alignment to change the alignment from center for the statistic column to be left. And so these are two like pretty basic functions here that I'm styling with. If you're familiar with GT, if you're not familiar with GT, definitely check out their website. But literally 100+ functions to style your table in exactly the way you'd like it. And similarly, you can use as flex table to create a flex table object and continue using those flex table functions to style your table. So this is one thing that I think is actually really wonderful about the package, is that no matter what output you need, no matter what your favorite package for printing tables is, although we are made as a companion to GT and some of the functionality only exists in GT where it's ignored in other packages. We'll show a couple of examples of that in a little bit. That you can really get any kind of table customized any way you need, formatted any way you want with the package. And I think that's one of the biggest strengths. All right, we are coming close to the end here. So please check out the website. We spent quite a bit of time, putting together documentation, the vignettes, the articles, these long form documentations. We have vignettes for TBL regression, TBL summary, inline text reporting. There's a gallery of a bunch of unique tables that may not be super straightforward to create for you until you actually see the underlying code. And you can say like, oh, that's actually not that bad. I can make this custom table that I needed pretty easily. So please check out the website. It's a really great resource. If you want to install the package, it's on CRAN, so you can just say install.packages gtsummary. We recently hit our 150,000 installations from CRAN, which is pretty wild. You can also install the development version from GitHub with install _GitHub. And I think it's also wonderful that when you're using a package with like a large user base, probably okay, I like that. That you won't be the first to try something. So if there were any issues, they've likely been smoothed out already, which is lucky for everyone else. I also wanted to share with you that in addition to gtsummary, I have a package called BeastFun. And what this is it's actually just kind of a miscellaneous package for me and my colleagues in the biostatistics department. So Beast is biostatistics, Fun is for functions, and we have an entire section in BeastFun which includes gtsummary related functions. So these are functions that execute on gtsummary tables or modify gtsummary tables in interesting ways. So you can see up here, the first example is the first two columns are just your typical TBL summary, but then we use this function add sparkline where you can add, for example, a histogram or a sparkline column for a visual representation of the distribution as well. Similarly, there's a function for your regression models called add inline forest plot, which will add these inline forest plots. They're very cute. Gives you the central estimate and then the whiskers for the confidence interval. There are tables for Likert data. You can actually convert a gtsummary table into a ggplot object, and then you can use packages like cowplot or patchwork to put your tables and ggplots right next to each other if you need that. There's all sorts of other things. Even actually, I forgot to mention, within the gtsummary package, there's a plotting method for your regression tables. So you can use all these modifying to make a beautiful regression table, and then you can pipe that object directly to the plot function, and it will give you a forest plot, which is really nice. And that's actually powered by ggalley package, which is really, really helpful. So BeastFun so there's a question here, does BeastFun support TBL survey regression objects? So we don't have a TBL survey regression function. We have a TBL survey summary, which is like TBL summary, but for survey data. But TBL regression can handle survey regression objects, like from survey GLM. So in that way, does that answer your question? If not, please add more. If it does, fantastic. All right. Thank you, everyone, for joining. And please, if you have questions, I actually really enjoy helping people out. But please, rather than emailing me, if you ask your questions on Stack Overflow and you use the gtsummary tag, I will be notified, and other authors of the package will also be notified. And I think we have 100% of the time respond within 24 hours, but typically within just a couple hours, we can respond and get you all sorted out. Let's see. All right, let's see. In sharing presentations, how do you suggest to show gtsummary tables, as PNG files or by calling the TBL object in the code chunk? So I think Malcolm has the best answer here because I think he's mastered both approaches. Personally, I have not mastered the approach of putting the actual gtsummary table into a Sherigan presentation. I always convert to an image and then put the image in because of what I believe to be conflicts with the CSS. But Malcolm, do you want to speak to that a little bit more?
I do occasionally bump into CSS conflicts, but nothing too rough in the themes that I use. Yeah.
Okay, great. Thank you. All right. Oh, thank you, Rebekah. That's really kind. Are there any questions?
I have one.
Yes.
I think I got an idea of when you started working on the package because of the number of installs by that timeline that you had. But when did you start? How long you've been working on this?
Oh, so it looks like we went to our first releases were the summer of 2019, but I believe that we started our internal package about 6 months before that. So maybe the beginning of 2019.
I see. Great, it's awesome. Seems like a lot of work too.
Thank you very much. Yeah, it's been a lot of work. It's also been a lot of fun, and I learned a lot. Actually, how this all started was my team. My first job, I was a SAS user, and then when I came to Memorial Sloan Kettering, my team was a Stata team, so I had to learn Stata, and we had all of these wonderful functions that were what we thought were wonderful function. Actually, they're not actually in retrospect, to summarize data, prepare regression model results, for example. And then when I saw R Markdown, it was very clear that that was the better option, but I couldn't get my entire team to migrate unless we had written similar functionality for them that we had already done in Stata in R. And so that was the beginning of this package. And, honestly, when I first started writing it, I didn't know how to program in R. Like, I love programming and I've always been like a good programmer in whatever language I'm using, but my R skills were very bad in the beginning of 2019. But I think I can proudly say I love R programming now, and I think I'm pretty good at it too.
That's awesome. Thank you.
All right. Are you and your colleagues able to submit output from gtsummary to a file, to JAMA, etc.? So what I typically do is in my role as a collaborator, as a statistician in the publications that we write, this is my workflow where I meet with our collaborators, we have a study aim, we write our statistical analysis plan, I write it, and then we all agree on it. And then I will implement our analysis plan. I'll write the method section of the paper, and I will write the results section of the paper, and I'll put all of the tables, listings, and figures in at the end. And that kind of starts the basis. This is a Word document that I output to, and that's the basis of our manuscript. So then typically the MD that I'm collaborating with will then write the introduction, and then they'll write the discussion, and bam, we have a publication. So that's our workflow. But if I were writing the papers all myself, in my typical workflow, I would absolutely write 100% reproducible workflow from start to end with my introduction, methods, results, discussion, all in one R Markdown document that would be rendered to a beautiful, beautiful paper. All right. Well, thank you very much for having me, Southern California R Users Group. It's been a pleasure.